Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Imran bin Magna. Today I want to present halfway and full wave rectification. Okay. What is the rectification? Rectification method to convert AC, which is alternating current, to DC direct current include full wave rectification and half wave rectification. In both cases, rectification is performed by utilizing the characteristic that current flow only in the positive direction in a diode. Today, I want to present about half-wave and full-wave rectifier using multi-sim software. To measure the value, I use Tetronic oscilloscope. I use 10 volt and 1 kHz for the power supply. I use 1 Whitworth diode. I use 1 resistor, which is 1 kilo ohms. So for the channel 1, for the input signal, I connect the wire between power supply and diode. For the channel 2, for the output signal, I connect the wire between diode and resistor. And lastly, I connect the ground to the terminal ground. To measure the value of input signal, so we can see I use channel 1 for the input signal. For the frequency, 1 kHz. For the amplitude, same as maximum value, which is 9.98 volt. And the type of signal, which is AC signal. So we can see that the measurement of value like period 1 millisecond, peak to peak 90.9 volt, value of RMS, value of minimum, value of maximum, and so on. Okay, next for the output signal, I use channel 2. So we can see channel output signal like frequency 1 kHz, for the period 1 millisecond, for the peak to peak 9.27 volt, value of VRMS 3.56 volt, and the maximum value 9.27 volt. For the half rectification for the input signal, during the positive half cycle of AC sine wave, the diode is forward biased as the anode is positive with respect to the cathode is negative, resulting in current will flowing through the diode. Moreover, the DC load is resistor. The current flowing in the load resistor is the proportional to the voltage and the voltage across the resistor load. Therefore, it be the same as the supply voltage. Okay, for the output signal, during the negative half cycle of AC sine wave, the diode is reverse biased as the anode is negative with respect to the cathode. Therefore, no current flow through the diode. Then in the negative half cycle of supply, no current flow in the load resistor as no voltage. Okay, next for the value of measurement. So we can see frequency and period between input and output has the same value, which is for frequency 1 kHz and for the period 1 millisecond. Besides, for peak to peak and value of RMS, the input signal greater than output signal. For the minimum value, the input signal has negative value while the output signal is 0. Furthermore, for maximum value rise time and fall time, the output signal less than input signal. We can conclude that when the input signal is positive, the diode is forward biased and it can conduct the current. Besides, when the input signal is negative, the diode is reverse biased and does not conduct the current. For the full wave, I use 10 volt and 1 kHz for the power supply. Side, I use 4 V2 diode and 1 resistor which is 1 kilo ohms. For this full wave rectifier, I use oscilloscope and it have two channel which is A and B. For channel A, the positive terminal I connect between power supply and diode D1, D3. For the negative terminal, I connect to the terminal ground. And for the channel B, the positive terminal I connect to the between diode and resistor, and the negative terminal I connect between resistor and diode D1, D2. So this is the result of the waveform for the full rectifier. The red color for the input signal and the blue color for the output signal. Moreover, to measure the value of input signal, I use this thing like ruler 1 and 2. To measure the amplitude, I move this thing at the maximum wave. So we can see for the input signal channel A, 9.9 volt for the amplitude. Besides, to measure the frequency, I must find the period first. So the period which is 1.0 millisecond. Next, with value of period, we can find the frequency using formula 1 over T. So the frequency get 1 kilo ohms. Besides, it also can use tetronic oscilloscope. So for the frequency, which is 1 kilohertz, and for the period, which is 1 millisecond. So we can conclude using the any oscilloscope, we can get same value. For the output signal, to measure the amplitude, we can use the blue color of waveform. So the amplitude for the output signal for the channel B, 8.5 volt, and the period which is 508.065 microsecond. During the first half cycle or positive cycle of the input voltage, the diode D3 and D2 are the forward bias, and the current enter the load resistor and return back to the negative power supply. During this half, the diode D1 and D4 are reverse bias and the current is not allowed to flow. Next, for the during the second half or the negative cycle of the input voltage, the diode D1 and D4 become forward biased and the current through enter the load resistor and return back to the positive source. Beside the diode, D3 and D2 are the reverse bias and the current is not allowed to flow. Next, for the value of measurement, the frequency is different value between input and output. Beside, for the period and peak to peak, the input signal greater than the output signal. Moreover, value of RMS, minimum and maximum, the output signal less than the input signal. And lastly, for the rise time and fall time, the input signal greater than output signal. Next, for the observation, the full wave rectifier are most commonly used in the rectification because they are more efficient compared to half wave rectifier. That's all from me. Thank you.